Okay, welcome back and good morning. Hope everybody had a good weekend. So this is our last week of meetings, and then we just have the final exam, the take home, which is due next Monday. And so just a reminder, you have a couple assignments, the last two assignments on the syllabus. Example 10.2 and the extra credit simulations, if you want to do that. Remember, that's worth 2 points. So I'd recommend doing it if you need the points. And so those two, example 10.2 and the extra credit simulations, both due today, and those again are the last two assignments. And I'll get your final assignments grades updated in the next couple days or this week. Okay, and then so all we have left to do today is what I want to do is a little review session, some practice problems for the take-home final. And so we'll do that. We'll go through a practice problem. We'll do a little review session, and then I'll just your final exam, the take-home is already on Blackboard, but we'll go through that real quick. And that's your last big assignment due, which is going to be due next Monday, just like the syllabus. And so make sure you email that to me by next Monday, May 24th. And the sooner I get all those final exams and everything, the sooner I can get your grades. And so I'm usually pretty quick at getting the grades done. And so I'll get your grades done as soon as I can, but I have to get the assignments in first. So that's how that goes. But let's do what I have planned for today, which is a practice exam, and talk about the final exam. All right, so if you go to on Blackboard, the final exam, spring 2021 section, there's two sections. The actual final exam in the bottom, and then the practice stuff here. So let's go ahead and look at some of the practice files here. So here's the practice exam for spring 2021. Okay, and so this practice exam will be similar to the format and the type of questions for your final. Okay, so they're going to be, I think, 5 questions. The first one will be on the cost regression 2. The second one will be on the cost regression 3. The third one will be on the hardware sales, where we did the exponential smoothing and the moving average stuff. And then I have 4 and 5, the last two questions, will both be on chapter 10 that we just did the last couple weeks on the simulations and probability distributions. Okay, so 5 questions, kind of like this. We'll go through this practice exam with the solutions, and you'll have that as a reference. But this is basically what you'll be doing. 5 questions, 20 points each, and these are the types. All right, so what I think is best to do now, like I like to do before I send out the final exam, or at least open it up, is go through some practice questions. So right here we've got practice exam final spring 2021. You can open up the practice exam final spring 2021 solutions. Okay, so here we go. And so let's go through these, and I'll explain how to get the questions. And if there's any questions, please let me know if you want to know how I got the answer, or if any questions come up, so you'll be prepared for your final. So here's the practice exam for the final. And so question number 1 will be on a multiple regression question from the cost regression 2. So number 1, estimating total cost for several products. So let's look at the screen cap for cost regression 2. You'll get one of those. And first, using data analysis, we did a multiple regression, similar to what we did in class in Excel, where total cost is the dependent variable, and units A, units B, and units C are the 3 independent variables. So uh, how is total cost affected differently by producing the 3 different products? And first part is write out your multiple regression equation using the coefficients that you get from the screen cap, from the summary output. And part B will be what's the interpretation of the R squared, remember that, and then also interpret the coefficients for units A, units B, and unit C that you get in the summary output. And then part C, just calculate total cost for month 16. So you're trying to find that missing value there. Okay, so you'll get a screen cap here of different months and how many units we produced of units A, B, and C, and then the associated total cost for a number of months. Okay, and you'll probably be asked to get either month 16 or month 17 total cost. Okay, and you have a summary output here of the regression results, where what you'll need to look at is the R squared and then the coefficients here for the associated variables. Okay, so the first part, part A, was to write out the equation based on the coefficients. So we're estimating how these different units affect total cost, and then we also have a intercept. Okay, so the equation would be your y variable, which is total cost, is a function equals the intercept, 8,740.04, plus the coefficient for units A, which is 7.90, times units A, so times how many units of A you produce, plus the coefficient for units B, which is 9.56, times units B, so times how many units of B you produce, okay? And then plus, finally, the coefficient for unit C, which is 7.31 times unit C. All right, so basically what this equation tells you is you can estimate total costs by using this and just plugging in how many units of A, B, and C you produce, and then you get total cost. So these are your numbers and coefficients. So when you want to estimate total cost for a given month or a given time period, all you got to do is plug in how many units A you're producing, how many units B you're producing, and how many units C you're producing, and then do the math. This plus that times that, plus that times that, plus that times that would give you the estimated total cost based on this historical data. But the general equation is this one, okay? So just know how to write out your equation here. Basically, all you're doing is use this general equation, and then when you get your exam, just plug in the intercept there, and then the different coefficients for A, B, and C there. All right, part B is to estimate, or just to interpret the R square. So the R square is going to be in the summary output right there. R square is 0.95. And what does that mean? So remember, the R square is the percent of explained variation in the dependent variable, which in this case is total cost. So this tells you how much of the movement in total cost you explain. So if that's the percent of explained variation in total cost, this means on a scale of 0 to 1, 0.95 means approximately 95% of the variation in total cost is explained by this multiple regression equation. So that's all you're doing there. Is this number, the R squared, tells you the percent of variation that this specification explains in the dependent variable, which in this case is always going to be total cost. So you explain the highest this number can go is 1, and that would be 100%, but this one explained about 95% of the total cost. So that means when total cost changes, specifying it this way, with this data, explain 95% of the total cost just by throwing in the different units produced. All right, then just individually interpret the coefficient for units A, units B, and unit C, and those are given there, 7.90, 9.56, and 7.31, respectively for A, B, and C. So the coefficient for units A is 7.90, and interpret that in dollars that represent total cost. So that means it costs $7.90 to produce 1 unit of product A on average. And so remember, that's just the coefficient is the effect on y when you change the x variable by 1. And if we produce 1 more unit, that's the effect on total cost, which means that that's the average cost for 1 unit of product A. So 1 unit of product A costs about $7.90. All right, it's the same thing for units B, except the cost is a little bit higher, $9.56. That means that it costs about $9.56 to produce 1 unit of product B on average. And also for unit C, you get a coefficient of 7.31, which just means that's the cost when you change unit C by 1 unit. Interpret that as producing one more unit C. That's the effect on total costs, which is a dollar amount. So it means it costs about $7.31 to produce 1 unit of product C. Okay, so that's what we're trying to do. We were trying to see uh, how much each product costs on average, and these are the costs. So units B is the most expensive at about $9 or $10, and the other ones are about 7 and 8. Okay, so then you can know, this is just a cost standpoint, but you want to know that if you're producing a bunch of units Bs, it better be worth it to like on the market because that's by far the most expensive one. All right, then what did question C ask? Question C asked, what just get total cost for month 16. All right, so make sure you look at the exact month that the question is asking. So here we have a blank for 16 and 17. It's only asking for 16, so don't worry about 17. Okay, so part C, total cost for month 16, which is asking for, is just plug in this equation. All right, and then plug in the units of each for that gives you you see there in the screen cap. So here's the intercept, 8,740.04 plus 7.90 times, right? This is units A. And I put in 450 because in month 16, look up here, and we're estimated to produce 450 of units A, right? So just look at the column in the chart and plug in this units A in month 16, 450 to get that one. Okay, then 9.5 plus 9.56 times units B, and we're estimated in month 16 to produce 660 units of B, so plug that in. And finally, plus 7.30 times units C, and in month 16, we're estimated to produce 540 units of unit C right there, and so plug in those numbers, and that's all you got to do. All right, and so we start with the general equation. We plug in the estimated values for A, B, and C, and then just put this in your calculator or do the math, and this should come out to about a predicted total cost for month 16, which looks like I got about $22,552.04. All right, so for this one, you're going to get a screen cap for the cost regression 2 with the different months and the units and the total cost, and then the summary output. And all you got to do is write out the equation. Okay. Part B is interpret the R square and the three coefficients for A, B, and C. And then part C, calculate the total cost for whichever, it's going to ask you for either month 16 or month 17. All right, so make sure you do the correct month.
Professor,
Yes.
how do you get the 0.95 for R square?
Oh, that was just given. So if you look at the summary output, right, so this, remember like in class we did the Excel, we did the data analysis and it gave us the summary output in that separate tab. So this is a screen cap of that summary output. So see how it's just right there? 0.95, it's just, it should be given in the screen cap.
Oh, okay, thank you.
Yeah. All right. So yeah, any more questions on number one here? Any parts A, B, and C, or everything clear on how we got the answers for this type of question? Okay. All right. Let's go over number two. And number two is going to be another multiple regression. And this one was the estimating products at 3 different plants. So here we had the binary variables, and this was equivalent to the exercise we did with the cost regression 3. So 20 points, number 2, estimating production costs at 3 company plants. Okay, this is the introduction of binary or dummy variables. So refer to the screen cap of cost regression 3 using data analysis. Uh, we estimated multiple regression with total cost as the dependent variable and units produced. Plant 2 and plant 3 as the 3 independent variables, x variables. So what is the multiple regression equation? Using the estimated coefficients. So this one, just look at the coefficients and write out your equation with total cost again as the y variable. Okay, so this one you don't even need the data. You just need the summary output. Oh, and all you need to do here is look at the coefficients for intercept, units produced, plant 2 and plant 3. So use that to write out your equation for the y variable, which is total cost again. So total cost y equals the intercept, 8,867, plus the coefficient for units produced, 41, times units produced. So you plug in however many units you produce there, plus the coefficient for plant 2, which is 5,187, times plant 2. And remember, this is binary, so um, if we're producing at plant 2, you're going to put a 1, there's going to be a 1 there. And if we're not, it's just going to be a 0. So this variable, plant 2, is either 1 or 0. That's it. So if it's at plant 2, you add this cost. If it's not, you don't. Okay? And then minus, only because it's a minus coefficient, the coefficient for plant 3, which is 5,000, which is minus 5,993, times plant 3. Okay, so that just means if we're producing at plant 3, put a 1 in here, and you subtract 5,993. So basically, like, um, this one's a normal x variable, so the number of units you produce, plug it in there. But these are binary, and if we're at plant 2, put a 1 in there, and that adds this much to the cost. If we're at plant 3, put a 1 in there, and that adds that much to the cost. If we're at plant 1, both of these are 0, and this is just the associated cost, or added cost. Okay, so you can do it the same way as before. Just put in your y variable, total cost. It's a linear equation, so put in your intercept plus the coefficient for units produced times units produced plus the coefficient for plant 2 times plant 2 minus the coefficient for plant 3 times plant 3. And this is only a minus because the coefficient is minus. Okay, and then again, we don't include plant 1 in the general equation because plant 1 is defaulted to plant 1 when both that and that are 0. That means we're at plant 1 then, and we don't want to double count, and so you always want to put one less binary variable than you actually have. So we're not specifying plant 1 specifically because when that's 0 and that's 0, we are at plant 1. Okay. Question B is, what is the interpretation of the coefficients for units produced, plant 2 and plant 3? All right, so interpret those 3 coefficients. The units produced coefficient was 41. What does that mean? All right, so this is just a normal x variable. When you change this by 1 unit, that's the effect on y, and uh, producing 1 more unit adds that much to total cost. So this just means it costs $41 to produce 1 unit on average. So when you produce 1 more unit, that's the effect of total costs, and that means more intuitively that it just costs $41 to produce 1 more unit. Now remember, the other two for the plants are binary variables. So this is uh, this is the change, or the difference in cost if you produce at one of these plants compared to plant 1. So there's an additional cost of producing at plant 2 of 5,187, So the plant 2 coefficient, 5,187, means exactly that total cost is 5,187 higher at plant 2 compared to plant 1. So it's this much more. It's this much more than the plant we didn't specify, which is plant 1. So producing at plant 2 is there's an average of it's an average of 5,187 higher at plant 2 compared to plant 1. So total cost is 5,187 higher at plant 2 compared to plant 1. And then the other one is nice because it shows you a minus, which means it's lower, all right? So this coefficient for plant 3, negative 5,993, means that it's a little bit, it's lower compared to plant 1. So total cost is 5,993 lower at plant 3 compared to plant 1. All right, so see that the coefficients for the binaries are always the comparison in the change in comparison to the ones that's omitted, and in this case that's plant 1. So it just total cost is 5,187 higher at plant 2, and total cost is 5,993 lower at plant 3, both compared to plant 1, right? And that's what that's how you interpret the binary. So we're not changing plant 2 or plant 3 by 1 unit. We're showing that this is the uh, additional cost, and this is the drop in costs comparing to plant 1. So plant 3 is the cheapest, plant 1's the middle, and plant 2's has the highest cost. All right, and then finally for this one, part C, what is the unique intercept for producing in each plant? Now, I think I referred to this in the exercise, but I don't know if we actually did this one um, in the problem. So just what we want to do here to specify the intercept is just basically calculate what you said here. All right, and so part C, you want to just list the intercepts for plant 1, plant 2, and plant 3. Now, plant 1 is not included here, and that's because when this is 0 and that's 0, that's the intercept. All right, so plant 1 is just the regular intercept because when you put a 0 in this binary and a 0 in this, these are gone, and that's your intercept. So the intercept for the one that's omitted, plant 1, is just the intercept that's given in the output. So the plant 1 intercept is 8,867, right? Just right there. Now, how do you get the plant 2 intercept? And I told you here that um, total cost is 5,187 higher at plant 2 compared to plant 1. So just add that to the original intercept. That's all you got to do because it's that much higher. So for plant 2, take the original 8,867 per plant 1 and add the additional cost of producing at plant 2, which is that coefficient of 5,187. If you add this intercept plus this coefficient for plant 2, you get the intercept for plant 2 is in fact 14,054. Okay, by that same logic, we're just going to subtract this from the original intercept to get plant 3. So plant 3 is the original intercept, which is for plant 1, 8,867 minus the intercept, minus the coefficient. For plant 3, 5,993, which 8,867 minus 5,993 gives us 2,874. Okay, so for the intercept one, just the intercept that's given is going to be the one for plant 1, and then whatever the coefficients are for plant 2 and plant 3, add those to the intercept, and that's your intercept. And if it's a negative, adding is subtracting it. So if it's a positive coefficient, add the additional cost, and if it's a negative coefficient, you're subtracting it. So you're adding these, but uh, adding a negative is equivalent to subtracting it. Okay, so for this one, you're going to interpret the coefficient, right? Just specify the general equation with the given coefficients, and you're going to interpret the coefficients for units produced, plant 2 and plant 3, and make sure you see how to do it for the binaries. And then you're just going to list the intercepts. Plant 1 is going to be the given intercept, and plant 2 and plant 3 are the additional or less costs that you talked about here compared to the plant 1. Okay, so number 2, any questions on this one? Any of the results we got here? Everyone good on how to solve this one? All right, let's move on to number 3. And number 3, this one's the forecasting weekly sales of hardware at lease. And so we had a bunch of practice with this one because we also did this in the stock market forecasting assignment. And so part A is going to ask you about calculating moving averages. Part B is going to ask you about calculating exponential smoothing. And then there's some other questions. So number 3, forecasting weekly sales of hardware at lease. So look at the screen cap for hardware sales and using a moving average, what is the week 105 sales forecast using an MA2, which you know is a moving average of 2, and then using an MA3, which is in turn a moving average of 3. So you want to get the estimate for MA2 and for an MA3. Okay, so I think for this one, you'll have a general equation for the exponential smoothing in the first screen cap. See, this is for the moving average, and the second one is the tab for exponential smoothing. So it'll be clear which one is which. Okay, so let's do part A. Let's calculate an MA2 and an MA3 using this screen cap. Okay, part A, if you want a moving average of 2 for week 105, all you gotta do is take the average of the last two um, sales datas, which would be week 103 and week 104. All right, that's a moving average of 2. So this moving average of 2 for week 105, remember, is just the average of the last two um, items, the last two pieces of data, or the last two variables. So for MA2 for week 105, just take the average of the last two, which is week 103 and week 104. So you want the average of 95.15 plus 85.10. Okay, so week 103 sales was 95.15 plus week 104 sales was 85.10. Divide that by 2 to get a moving average of 2. And your forecast for week 105 by just averaging the last two would be $90.13. Okay, so for the moving average, you don't need to use the actual moving average columns in your calculation. Just take the appropriate average of whatever it specifies. So MA2 is the average of the last two. Then MA3, you can probably guess, is the average of the last three. So MA3 forecast of week 105 is the average of the last three sales datas, which is 102, 103, and 104. So you want this plus this plus this, and a moving average of 3 is just divide that by 3. All right, so MA3 for week 105 is the sales for week 102, 82.90, the sales for week 103, 95.15, and the sales for week 4, 85.10. So the last three divided by 3 to get the moving average of 3 would give us an MA3 week 105 sales forecast of 87.72 or $87.72. That's the actual sales. All right. Part B. Look at the screen cap for the hardware sales for the exponential smoothing tab. And what's the week 105 sales forecast using an alpha equals 0.8 and an alpha equals 0.9. Okay, it's a you can use the general equation or the one we've used in class, which is just your forecast is alpha times the last observation plus 1 minus alpha times the last forecast. Okay, so the second one, the one that has the exponential smoothing tab highlighted, is the one you want here. And you'll see a column of the weeks, you'll see a column of the actual sales, and a column for alpha equals 0.9 and alpha equals 0.8. So just use the correct one there. So you want these two blank cells that are highlighted. So your week 105 sales forecast for using an alpha equals 0.8 is alpha 0.8 times the last observation, okay, which is week 104, so 85.10. And then plus 1 minus alpha. So if alpha is 0.8, the 1 minus alpha has to be 0.2. Right? 1 minus that is 0.2. And times the last um, forecast in the alpha equals 0.8 column, which is 93.68. And if you take that plus that times that, then you get a forecast week 105 with an alpha equals 0.8. Your forecast would be $86.82. Okay, so for the exponential smoothing, just take alpha times the last um, observation, which is going to be week 105 sales, plus 1 minus alpha times the last forecast, which is going to be the week 104 for the appropriate column. So it's alpha times that plus 1 minus alpha times that. All right, same thing for alpha equals 0.9. The only difference is your alpha is different, your 1 minus alpha is different, and your forecast for an alpha 0.9 is different. Okay, so the week 105 for alpha equals 0.9 is alpha 0.9 times the last observation, which is week 104 sales, $85.10, plus 1 minus alpha. So if alpha is 0.9, then 1 minus alpha is 0.1 times the last forecast for an alpha equals 0.9 process, which is right there. Alpha equals 0.9, 104 is $94.22. And if you take this times this plus this times this, then you get exactly $86.01. So again, same equation, alpha times the last observation, 85.10, plus 1 minus alpha times the last forecast, which in this case is 94.22. Okay, so you're basically just looking at the week 104 row, but make sure you put the alpha on the appropriate sales data and the 1 minus alpha times the appropriate forecast column. And you can see that they're all a little bit different, but they're all like in the 90s and 80s. And so make sure that your answers are something in the correct realm. So you should get something that's 80, 90, 100, something in that range, or maybe a little. So if you just double check that your answers here make sense given the numbers you see. So if you got like 5 million or negative 10, then something's wrong. So make sure that the numbers at least kind of fit in what you see here in the columns. What's number part C is what does the alpha do specifically in an exponential smoothing model? And so remember that alpha controls the weight that we place on the last observation. So increasing alpha puts more weight on the previous observation. All right, so I think for part C, that's gonna be the same question you get on your final. So just that's your answer. And then let's see, D, what exponential smoothing model would you use if your historical data exhibited an upward or downward trend? And what exponential smoothing model would you use if your historical data exhibited a seasonal pattern over time? So remember we did these in class, but we didn't have the software to estimate them, but we learned about uh, how these types of models would work if you see a trend or seasonal or both. And we saw that if your data had a trend, if you plot the data and you see an upward or downward trend, then you want to use Holt's linear trend model, right? So Holt's model was for if your data specifically has a trend, you can use an exponential smoothing model that incorporates that trend. And if you had seasonal data, so remember we looked at, I think it was the soft drink sales that had historically higher sales in the hotter months and lower sales in the colder months. All right, so we can expect that to continue and to incorporate an exponential smoothing model with seasonal aspects. You would use the Holtz Winters or the Winters model. So either one is correct. So for a trend, use Holtz model. For a seasonal, use Holtz Winters, or you can also call it Winters model. All right, so that's number three. Questions on this one. So make sure you know how to calculate the moving averages, and make sure you know how to calculate the exponential smoothing estimates. And then parts C and D will you already have the answers here, but make sure you given that you'll probably get so you might get an MA2 or MA3, MA4, MA5, and just make sure you can plug in different alphas to get your exponential smoothing uh, answers here. Okay, so questions on this one? How to do this? How to get the solutions for number three?
Wait, Professor.
Yes.
Um, so for the MA2, for the 95, 15, and 8510, that's just like uh, the sales for 103 and 104. Like we just use those values to solve it.
Yeah. So whatever. So if you do an MA2, you're gonna look at the moving average screen cap here, and an MA2 for whatever month you're forecasting is the average of the last two observations. So from the sales data. So like if you're going to be doing a 105 forecast, so an MA2 is the average of these last two, an MA3 is the average of these last three, an MA4 is the average of these last four, and just to do the average, just uh, add them up and divide by the number of items. And so for the moving averages, you don't need the moving average columns here, but you do need them for the exponential smoothing. So yeah, just whatever your moving average is, then you want to take the appropriate average based on the historical sales data. So MA2 is the average of the sales for 102 and 103 or 104. MA3 is the average of the sales from 102, 103, 104, and so on. So just uh, calculate the appropriate average based on the specified moving average.
Okay, got it. Thank you.
Okay, you're welcome. Okay. All right. So yeah, that and yeah. So and when we go through this, I'd recommend if you have time before you do your take home final, just try to do these questions without looking at the solutions and see if you get the same answers, and that'll prepare you there. But all right, we got a couple more, and the last two are both on the simulations or probability distribution ones from chapter 10. All right, so we did a bunch of these last week for the ordering calendars and ordering books. So number 4, this is going to be a simulation with Excel only at Walton Bookstore. So part A, is refer to the screen cap of ordering calendars for Excel only one. And what is, part A, what is demand for replication one only? So we did a bunch of simulations, but I just want you to understand the logic and the math for one simulation, and then that's all you need to know. So for simulation one, what would be, so for the very first one, we don't need to do all the 1,000 simulations. I just want you to understand the first one. And specifically, how do you get the demand from the random number? So these are the, if you look at the screen cap, this is the demand distribution, which means that these are the possible values of demand, and these are the associated probabilities. And so if you have to just know how to go. Basically, you're just doing a VLOOKUP manually, and that's all you're doing based on the random number. So see how we got in replication one, we have a random number of 0.9. Now, what demand value would that give us based on the lookup table? So remember, we specified it so the like 30% of the random numbers would give us 100 because there's a 30% chance on that, and there's 20% of the random numbers would give us 150, and so on. And so just look at the ranges. And so if the here's the random number 0.91, so that's in between 0.8 and 0.95, which would mean that that gives us a demand of 250. So this is how you kind of look at the breakdown. If it's between 0 and 0.3, demand is 150. Okay. If it's between 0.3 and 0.5, demand is 150. Or sorry, if it's between 0.0 and 0.3, demand is 100. If it's between 0.3 and 0.5, it's 150. If it's between 0.5 and 0.8, it's 200. If it's between 0.8 and 0.95, it's 250. And if it's over 0.95, it's 300. Okay? And so, again, the reason why we do it like that is because you can get a random number and you'll get a demand based on its probability given the number of choices you gave it for each one. So the point is that this 0.2, or sorry, this 0.95, go to lookup table and that's in this range, right? And if that's in this range, if that's above 0.9, 0.8 and less than 0.91, that means our demand is 250. Okay, so for part A, all you have to know how to do is take the random number that's in the screen cap and go to the lookup table and just tell me what the demand is based on that random number. Okay, so with a random number of 0.91, your demand is 250. Okay, B, or we didn't look at the question yet. So B, calculate revenue, ordering costs, and refund for replication one only. Okay, so revenue. With a demand of 250, so remember revenue is always the unit price. So here's the cost here. So it costs $5 to order a book. We sell it for 15, and the refund is $1 if we get a refund. And we're going to order 200, and then these are the demand distributions. Okay, so your answer for B, your answer for everything, depends on what you got for part A, which is a demand of 250. So remember the revenue that we get is always which is lower, demand or order quantity, times the unit price. So because demand was 250 and order quantity is 200, okay, we only ordered 200. So we we can only sell what we ordered. So whichever of these is lower, multiply that times the unit price of 15. So for this case, it's 200 times 15, which is a revenue of 3,000. All right, so again, for revenue, take whatever number is lower, demand or order quantity, and just multiply it by the unit price. Okay, and then cost is the easiest one. Cost is always order quantity times unit cost. That's it. So order quantity times unit cost. In this case, it's 200 times 5, which is 1,000. And then do we get a refund? So remember this, you have to look at the screen cap and the demand, and you only get a refund if you order more than demand. Okay? Did we order more than demand this time? No, we didn't. So demand was 250. We only ordered 200. So there's no extras to sell back because we didn't even order enough. So you only get a refund of $1 per calendar if you order too many. So if you overshoot demand, you can sell that surplus back at $1 per calendar. In this case, we didn't. We sold everything we ordered. We actually could have used 50 more, but we don't get a refund here because we sold them all. So refund's going to be 0, and I just put it would be $1, but because there's no surplus, so because order quantity didn't exceed demand, that number is 0. So we don't get a refund in this situation. All right, and then part C. What's profit for replication 1 only? So profit is always going to be um, revenue plus refund minus ordering cost. So in this case, profit is a revenue of 3,000 minus the cost of 1,000, and then if we got a refund, we'd put it in there. But I just put it in there for thoroughness, but it's a 0 for now. So if you get a refund, you got to add that. But profit is always going to be revenue minus cost plus refund. In this case, it's just 3,000 minus 1,000, which gives us a profit of 2,000. Okay, and finally, part D is refer to the data table and the cluster column chart for average profit versus order quantity. Which order quantity gives us the highest average profit? Okay, so all I gotta do is scroll down to this second screen cap and just tell me which order quantity is associated with the highest average profit. So you can look at the chart and see it looks like it's 200, and just confirm over here in the chart that 200, right? So there's no other, yeah, so it's 200. So this average profit of 1,450 and 30 cents when you order 200 books calendars is the highest. So just see what order quantity gives you the highest average profit in the chart, confirm it in the table, and then just tell me which order quantity it is. So in this case, it's ordering 200 would give us the highest expected average profit. So just order quantity 200 gives us the highest average profit. All right, so question we have another one. Question number 5 is pretty much the same question, so you're gonna do it. We'll get 2 examples here, but questions on number 4: how to get demand, how to get revenue, how to get costs, how to get refund, how to get profit, or part D, how to just report the highest order quantity. So questions on any of these components or how to get the solutions for this one. All right. Okay, let's do the last one. We'll get extra practice at this type of question, and you'll have 2 of these on your take-home final. So number 20 or number 5, 20 points. Another simulation with Excel only at Walton Bookstore. So we got refer to the screen cap of the ordering counters. Excel only 1 again, and let's do it again. What's the demand for replication 1 only? All right. So again, in the first screen cap, look at the random number and report the demand based on the demand distribution that goes along with that random number. All right, and let's see. I'll try to make it on the exam. I won't make it so it's exactly one of the numbers because then it gets a little confusing that So remember if I said if it's between 0.0 and 0.3, it goes to 100 and so on. So if it's exactly 0.3, which in this case it came out to be, um, then it would go to the number. Just if it's exactly the number, just give the number that's right next to it. Okay, so basically, um, here's the random number 0.3, and if the random number is 0.3 and less than 0.5 in that range is 150. Okay, even if it's exactly that number. So I guess it might even be easier if the random number is exactly one of these, then just give the demand next to it, which in this case is 150. But normally it's going to be in the range. So remember, uh, if it's between 0.0 and 0.3, it's 100. If it's between 0.3 and 0.5, it's 150. If it's between 0.5 and 0.8, it's 200. If it's between 0.8 and 0.95, it's 250. And if it's bigger than 0.95, it is 300. So your demand is going to be one of these based on the random number, and it's calculated to give a demand based on its associated probability. So there's only, the ones with a higher probability give you more chances at the random number. Okay, so the point is a random number of 0.3 gives us a demand of 150, right? Okay, so part B is you're going to calculate the revenue and the ordering cost and the refund for replication one only based on your demand that you got of 150. Okay, so revenue is always, um, so make sure you look at so here's the demands. We're going to order 200 again, but the costs are a little bit different. So that it only costs $1 to order the calendars. We sell them at $3 and the refund is 50 cents per calendar. Okay, so the cost data is a little bit different, but the equations are the same. All right, so remember revenue is always what's lower, demand or order quantity times the unit price. So demand was 150, or yeah, and order quantity is 200. So which one is lower? Obviously, demand 150 is lower than 200. So the revenue is the lower of the two, order quantity and demand times the unit price. So it's going to be 150 times 3. Okay, 150 times 3 is 450 in cost and in revenue, and the cost is always order quantity times unit cost. So 200 times 1, cost of 200. And this time we do get a refund because we ordered too many, right? So see the difference? If we order more than demand, then we get a refund of the difference at 50 cents per calendar. So we ordered 200, we sold 150, but the difference, 200 minus 150 is 50. So we get a refund for those 50 books or 50 calendars of 50 cents per calendar. So take the difference, 200 minus 150, that's 50. 50 times 50 cents is $25. Okay, so we get two nice examples where one, um, we didn't order enough and we don't get a refund, and two, we ordered too many and we do get a refund. So you can see the clear difference between this one and problem 4. And part C, calculate profit for this replication 1 only. And so profit's going to be revenue, 450, minus cost, 200, and this time we get a refund. So add that plus 25. Okay, 450 minus 200 plus 25 gives us a profit of $275. And D, look at the data table and the cluster column chart for average profit versus order quantity, and which quantity gives us the highest average profit. So just look at that second picture. It's a little hard to see, but it looks like 250 ordering 250 gives us the highest average profit. And you can confirm that over here. If you look at ordering 250 gives us average profit of 304, and all the other options are less than 300. So that's the answer. So you can look at the chart and the table and just find which one gives you the highest average profit. In this case, ordering 250 would do that. So order quantity 250 would give us the highest average profit. All right, so again, questions on this one. Everyone sees how to get demand based on the random number and the
Wait, Professor.
yes.
Um, where'd the 50 come from for refund?
Oh, okay. So the refund. So the all right. So the refund is you get a refund for this type of problem if you order more than demand. So we know that demand is 150, right? We ordered 200. Okay, so 150 of those 200 got sold, and the remainder, uh, 200 minus 150 is the difference of 50. Okay, so it's the difference if if order quantity is bigger than demand, which it is in this case, just take the difference, and what you have left, you're going to get a refund for those extra calendars. So 200 minus 150 gives us the 50, right? Yeah, you see that?
Okay, thank you.
Yeah, you're welcome. Okay, so yeah, just again, if you get a refund for each calendar if the order quantity is bigger than demand. So if the order quantity is bigger than demand, like it is in this case, take the difference, 200 minus 150, and you get a refund of 50 cents per extra calendar. In this case, there's 50 extra. All right, and just compare that to the previous one where there was no refund because order quantity was 200 and demand was 250. So in this case, we didn't order too many. In fact, we didn't order enough. So if order quantity is less than demand, no refund. If order quantity is bigger than demand, you get a refund of the unit refund times the difference. Yeah. All right, so uh, more questions on this one. So everyone sees how to get the demand based on the random number and the lookup table. Also, how to calculate revenue, cost, and refund in profit, and then part D is just look at the chart and find the highest order quantity. Okay, so we're good on these ones. How to solve this? All right. Okay. All right. So that one's there. The practice exam with the solutions. You got that as a reference, so you can look at that when you do your exam. And so let me final exam spring 2021. And right here, the final exam spring 2021. There's a Word document and a PDF, both the same exact test that you have to do. So let me just pull this up. All right, so here it is. Here's your final exam. All right, so show all your work. That's worth 100 points, the same weight as the two midterms. And if you could email me a PDF or a Word document like you did with the previous test, that would be preferred. Okay, so prepare your answer sheet as a PDF or Word document if you can do that. And like it says in the syllabus, and like it says here, submit your answer sheet to me by email by next Monday, May 24th, and you got my email address. And again, this due date's on the syllabus. It's also right here on the document. So your answer sheet is due by next Monday, May 24th, by email. All right, and you don't have to wait till next Monday. You can, whenever you're done, you can email it to me. All right, and you'll see that you got the same type of questions that we went through. So you got one on the multiple regression with the total costs and the different units. All right, cost regression 2. Number 2 is going to be on the cost regression 3, where you got the multiple regression with the binary variables you're producing at different plants, and do that one. Number 3, you're going to calculate a couple moving average forecasts and exponential smoothing forecasts based on this information and this information. And then 4 and 5, you're going to look at the screen caps, and based on the random number, you're going to get demand, revenue, ordering cost, refund, and profit. All right, and then just find the highest profit with the associated order quantity, and the same with this one. All right, and probably one of them is going to be a situation where you get a refund, and one of them is not. Okay, so you'll get both methods there. All right, so 5 questions. Um, try to make your answer sheet a PDF or a Word document, and that's due next Monday, May 24th. So everyone good on what to do here for the final? All right. Okay. All right, so there's that. And so just let me wrap up a few things here. All right, so last exercises that are due, or last assignments. So make sure the example 10.2 and the example or the extra credit simulations, those are both due today. All right, so post those in Blackboard if you haven't done that already. And then I'll get your final assignment grades updated later this week. And then most importantly, make sure you get your take-home final emailed to me by next Monday, May 24th. And that is the last big thing we have to do for this class. And so basically, once you get your final done, I've done everything I wanted to cover on the syllabus, or everything that was on the syllabus has been done. So we have one more meeting this Wednesday for WebEx, and so I don't have any new information, but I'll just because I got everything in the syllabus done, I'll have the WebEx meeting on Wednesday at 7:40. But it's just basically going to be office hours, okay? And so if you have any questions on any assignments, or the final, or anything about your grade, please come on Wednesday because I'll be there. It's basically going to be virtual office hours because I want to keep that last meeting just because I have it scheduled. But we've done everything I want to do on the syllabus, assuming you get the last 2 assignments and the final done. So nothing new to go over, but I'll be here on Wednesday morning if you want to come with any questions. It'll just be office hours, okay? And so that's our last meeting, Wednesday, office hours, and then make sure you get your last 2 assignments and your final in, and that's basically it. So, all right, well, thank you guys for joining, and if you want to come Wednesday, it'll be office hours. If not, just let me know if you have any questions. But I look forward to seeing your answer sheets via email. And so, thanks again, and thanks for a great semester.
Thank you.
Thank you.
Thank you so much.
Thank you.